operate between 10 and 0 volts. Well, how would I do that, guys? Somebody said it. Yeah, we would set up a voltage divider. So I would come up here and I'd say, okay, so I've got my pot, and it's a 10K pot. Okay. And up here I'm putting, what did I say, 24 volts, but I want it to set it at 10 right there. Not 10K, Rich. 10 volts. So give me some ideas. Put a resistor in there to drop how many volts? So I would come up here and I would put a fixed resistor right here. And then I would want that resistor right here to drop. We want 10 volts right there, so we want it to drop what? 14 volts. And of course we're taking our output right. Okay, so what am I going to do? How am I going to calculate the size of that resistor? What's R equal to? Yeah, but I agree with you, but what's the formula for R? I got to calculate this guy right here. This is, that R is 10K. What we're trying to do, Tim, is we're trying to come up with the R of that resistor right there. Okay, B. Well, I know I want B to be what? I want B to be 14 volts. Right? Everybody okay? What current am I going to use? Well, I don't know the resistance. I'm trying to figure an R. Well, how can I get an I if I don't have an R? All I know is I want that resistor to drop 14 volts. What R? Why 400? How'd you come up with 469? Guys, you're setting the size of this resistor. Well, so let's do a current. We don't want a high current, right? Because the high current will determine the wattage of those resistors. So if that's a quarter watt pod, I don't want to exceed a quarter watt. But I would just make up a current. Let's say I do 10 milliamps. Where did that 10 milliamps come from? No, it didn't come from the 10K, it just came from me. I just said, okay, I know I'm on size an R. That 10K is going to conduct a current. All I want to make sure is I don't exceed the wattage rating of the pod. So that means a quarter watt pod, that means that pod could do what? It could do 250 milliwatts. If I exceed that, then the pot might burn up. If I don't exceed that, then the pot is not going to burn up. I can choose a current that's less, but I don't want to choose a current that's more. I don't want to choose a lot of current because a lot of current means it's going to be wasted power, right? You understand? And I don't want to choose an extremely small current because the smaller the current, the more noisier the system's going to be. So 10 milliamps is good. 100 milliamps is good. 1.4K. And what are 3 things that a resistor is rated in? Yeah, we got a tolerance. We got a watt, a wattage, and then we got the actual resistance A itself, where you can, huh? What? What? I shouldn't say resistance. I should say resistance. Okay. A lot of people don't think about that. They say, I want $100 resistor. A lot of times they think they can go up and pick $100 resistor. And then they put it in their circuit and it burns up. I think I told everybody about my power supply lab that time, right? Yeah, they kept saying, my power supply keeps burning these resistors up. Something's wrong with my power supply. And they needed like $100 resistor and they was just doing what? They'd say, well, that's brown, brown, brown. They'd go find a brown, black, brown. And they'd stick it in there. They'd burn it up. They'd go back and do what? Get another, grab another. And they said, something's wrong with my power supply. It keeps burning these resistors up. Huh? You'd be surprised how colorblind people literally adapt.
Really?
Yeah. I mean, it's amazing to me. It's very amazing. We do. We've got some colorblind people.
That's what.
They normally you can tell a lot of them will use these. So they'll pick one that's close, and then they'll measure it. Oh, in the Navy, when I was in the service, you could be colorblind.
Yeah, I guess
that was one of the things. Well, what if we wanted a span of between 10 volts and 3 volts? Well, then I would do what? I would have to put another resistor right there. This resistor right here would drop 3 volts. Right? You understand? This resistor right here would drop 7 volts because 3 plus 10, because I want 10 right there. So this guy here would drop 7 volts, and now I would do all my other resistors. So what we could do is we could literally set the span anywhere from any voltage to any voltage, right? You understand that? Depends on the system that we're in. So you'll see these a lot, 3 resistors, where they use the pot, and then they'll have a resistor at the top and a resistor at the bottom. So why are they doing that for? Because they're setting the span between, it's not from a voltage of 0, it's from a voltage to a watt, to a volt. So yeah, we can do that. We okay? So this is setting the span. You'll see this done a lot in the pot. So that pot right there went down to like 1 volt. I don't know if there's a resistor down there or not. I might not have pushed it down. Because that pot is spring loaded, and it's that pot on that is spring loaded in the center. So literally, when you don't do anything, if we got 10 volts, it output 5 volts. And you had to literally push it down or push it up. You notice what I was doing on that. So when I looked at the output of the coming into the A to D converter, it was setting at pretty close to 5 volts.